All right, so chapter 8, section 1 is called Finding the Angle Measures in a Polygon. So now we're branching outside of just triangles. We're talking about polygons, okay, which are figures with different amount of... The parts of a polygon are on this first slide. Each segment that forms a polygon is a side of the polygon. The common endpoint of the two sides is a vertex of the polygon. And the segment that connects any two non-consecutive vertices is called a diagonal. So a polygon is just that closed-sided figure. A, B, B, C, C, D, D, E, and E, A are your sides. A, B, C, D, and E are your vertices. And then one of the diagonals there is drawn. But it's any segment that connects two non-consecutive, which means one after the other. So this is also a diagonal. This is also a diagonal. This is also a diagonal. Okay. Any segment that connects two non-consecutive vertices. If it connects two consecutive vertices, it's a side. Okay, quick refresher on the names of the polygons. So 3 sides, triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, and 12 dodecagon. Anything else is just n-gon, which means if it has 23 sides, it's 23-gon. So we call it a 23-gon. God bless you. I don't know why 11 got left out. Poor little 11 doesn't have a special name. Okay, but it's not. You would call it an 11-gon. To find the sum of the interior angle measures of a convex polygon, you can draw all the possible diagonals from one vertex of the polygon, and it will create a bunch of triangles. What do we know about the sum of the angle measures of a triangle?
It's 180.
180. So a diagonal, because it connects non-consecutive vertices, okay, which means if I start from a single point, if I started from here, I can't connect it to the consecutive vertices, which is the one to the right of it, the one to the left of it, but I can connect every other one. So there are the number of sides minus 2 for those 2 vertices, number of diagonals. So in a quadrilateral, there's going to be 1, because 4 sides, subtract 3 from it, just kidding. 4 sides, no, there'd be 2. But if you do, so number of diagonals is minus 2. But from a single vertices, if this hexagon, which is hexagon has 6 sides, has 3 sides. The pentagon has 2 diagonals. So if you're doing it from one single vertex, then it's the number of sides minus 3 would be how many vertices you can get. I mean, how many diagonals, sorry.
How come you can't connect like that?
You can. It's saying from one. So this hexagon has this diagonal, right? And this diagonal as well, right? It has this diagonal, this diagonal, this diagonal. So if you're just finding out how much it is from one vertex, you're picking, that's what these are. You've picked one vertex to do it. That's why they don't have all of them. So what's happened here is from this hexagon, we have formed 4 triangles, right? 3 diagonals, but 4 triangles. In my quadrilateral, which, let me erase this one, because we're saying just from one. Just from one vertex. In that quadrilateral, there's 2 triangles, 1 diagonal, 2 triangles. In the pentagon, there's 2 diagonals, 3 triangles, okay? But there's a formula to this, so you're not going to have to do this every time. This is just where the formula comes from. This is the sum. So the sum of the interior angles in a polygon is found by doing n minus 2 times 180. So the number of sides minus 2 times 180. That would be how many triangles you could get in there, okay? So think about a triangle. If the number of sides is 3, 3 minus 2 is 1. 1 times 180 is 180. Number of degrees inside, right? In a triangle. How about a quadrilateral? Quadrilateral would be 4. 4 minus 2 is 2. 2 times 180 is 360. Pentagon would be 5 sides. Minus 2 is 3. 3 times 180 is 540. Hexagon, 6 sides. 6 minus 2 is 4. 4 times 180 is 720. So you don't need to memorize this. You just need to memorize this, because if you know the number of sides, you just plug it in. Okay? So the sum of the interior angles would be n minus 2 times 180. That's the first formula you've got to know. These are corollaries. Remember, it's corollary or a theorem and a corollary. The theorem 8.1 is called the Polygon interior angles theorem, which says what we just discovered. The sum of the measures of the interior angles of a convex polygon is n minus 2 times 180. A corollary, which is something that can be determined from the theorem, says the sum of the measures of the interior angles of a quadrilateral is 360. Because I would know quadrilateral is 4 sides, 4 minus 2, 2 times 180, 360. Okay, so something easily determined from that first theorem. Anybody still coming? All right, and then theorem 8.2 is called the Polygon exterior angles theorem. And this says that the sum of the measures of the exterior angles of a convex polygon, one at each angle, or one at each vertex, sorry, is 360 degrees. So if I took my initial polygon here, 1, 2, 3, 4, 5 sides, so this is a what? Pentagon, right? And each vertex, I drew one exterior angle. So there's 1, 2, 3, and 4, and then 5. And then the sum of all these angles is 360. So this does not change. It's any polygon. It could have 5 sides, it could have 50 sides, and the sum of all the exterior angles is still 360. The interior is going to change by the number of sides there are, but the exterior does not change. Sum is always 360. So let's go a step further with interior, and let's say that it asks you to find each interior. So instead of finding the sum, which the sum is that n minus 2 times 180, it just wants one of the angles. First of all, this can only work for a regular polygon. What's a regular polygon? What's regular mean? Goes back a couple of chapters. Do you remember what a regular?
It's not concave?
Oh,
All the sides and angles are equal.
Good. So a regular polygon means that all the sides and all the angles are equal. It's the only time this works. Okay? To find each interior, I would do the sum of the interiors, which is here, n minus 2 times 180, and then divide it by the number of sides.
All sides and angles are equal.
All sides and angles are equal, yeah. So it won't ask you for each interior if it's not a regular polygon, because you can't find it. You can find the sum, but you can't find each. All right, so this says find A, the sum of the interior and the sum of the exterior angles. And A is a heptagon. How many sides does a heptagon have? 7. So interior, sum of the interior would be n minus 2 times 180, which is 7 minus 2 times 180, or 5 times 180. Which is 940. Now B says find the sum of the exterior.
yeah, no,
Did I do that wrong? 180, I just probably, yep. Oh, that would help if I did the right thing. Hang on. Here we go. There we go. Just making sure you're paying attention. Okay, sum of the exterior, And this is the question that you pray for because what's the answer? 360, no matter what. So here's the sum of the interior. Sum of the exterior is 360 no matter how many sides. Okay, B, same process, different number. Oh, that's a 4, like I carried the 4. So this time I get 15 times 180. So I do 15 times 18, carry the 0. So 17 minus 2 is 15. 15 times 180, 2,700. That's right? I'm on a roll now. Okay, all right. And the sum of the exterior, 360. Okay, now this one says find the measure of each interior and each exterior. So keywords you have to look for, interior, exterior, because that will tell you which equation, right? And then the word sum or the word each. So in this case, I'm looking for each one, and each one means I'm going to take the sum and divide it by what? The number of sides, okay? So the each interior is n minus 2 times 180 divided by n. What do you think each exterior angle is?
260. By the number.
By the number of sides. 360 divided by n. So I know it's 360 no matter how many side lengths, right? To find each one, because there's one at each vertex, and there's one vertex for each number of sides. Then to get each exterior, I do 360 divided by n. So this is when your skills come back, right? Because there's a lot of multiplying, dividing, and all of that stuff. So a quadrilateral has how many sides? 4 sides. So I know this is 4. My numerator would be 4 minus 2 times 180. And then I'm going to take what I get from that and divide that by 4. So I can do this a couple of different ways. Multiply out your top, so it would be 2 times 180 divided by 4, which is 360 divided by 4, which is 90, which should make sense because what's a regular quadrilateral? A square would be a regular quadrilateral, right? 4 right angles. A rectangle would be a regular quadrilateral. Well, no, a square is just a square. And then the other way to do it is as I'm going, simplify it. So like I could say, okay, this goes in here 2 times, and then it's 180 divided by 2. So you can reduce it as you go, or you can wait till you get to the end. The bigger the numbers, the easier it's going to be to reduce it as you go. I haven't even got there yet. No, you're fine. So then this one, each exterior would be 360 divided by 4, which is also 90 degrees. So regular quadrilateral, both each interior and each exterior would be 90 degrees. With me so far? Yeah? Okay, an octagon. So we're doing the same thing, but this time n is 8. So 8 minus 2 times 180 over 8. 6 times 180 over 8. And again, I can either multiply out the top and then reduce, or I can reduce as I go, make them smaller numbers. So this would be 3 and 4. 540 divided by 4. 1, 3, 5. And then the exterior would be 360 divided by 8. So I can reduce this as much as I want to. So I could go into 4 times, right? It would be 92. 90 divided by 2 is 45.5 or 45 and a half. No, holy moly. 45. Doing good today. Okay, you do. Alright, so 15 gone would be 15 minus 2 times 180 divided by 15. This is 13 times 180 over 15. Again, you can multiply it out or you could reduce it. 180 and 15 are both divisible by 5. I could start there. So it'd be 36 over 3. And I could go further. 12. And then I just do 13 times 12. (156 degrees). Raise your hand if you got it right. Good. Okay. And then each exterior 360 divided by 15. And again, I can reduce it, make it easier on myself. 5 goes in here 3 times and into here 72 times. And then that goes in again. 72 divided by 3, 24. And then the 20 gone. So 20 minus 2 times 180 over 20. 18, 180 over 20. I can reduce this. 2, 7, 162. And then exterior 360 divided by 20, which is 18 degrees. Questions on any of those? Okay, let's see if my wife. So this is like question like 24, 25. Okay, there's one similar to it. So you're working backwards this time. This time they're giving you that a single angle is 135 degrees. And what you want to find out is what n is. So you're working backwards. Okay? So think about how we typically solve this, right?
But how are you, like, how do you know?
That's what I'm going to show you. Right? So how you would work if I gave you the n is I would do n minus 2 times 180 over n, right? And that would give me the angle. You with me so far? I bet if you just hang tight, I'll show you how to do it. Yep. So now we still have one unknown. We don't know n, right? But we do know the angle. So if n minus 2 times 180 over n equals 135, how could I solve for n? So I can multiply n on both sides. This cancels. I get n minus 2 times 180 equals 135n. Distribute the 180. So I get 180n minus 360 equals 135n. Then I want to get both ends the same size, so I subtract 180. And then I want to get n by itself, so divide by negative 45. And I can simplify this one. They're both going to become positive because it's a negative divided by a negative. And then I can reduce it. So they're both divisible by 5. I can start there. This would be 9. This would be 72. And what is 72 divided by 9? 8. So you're going to see questions like just like that in the homework. So this time they're giving you the angle measurement but not the n. So you're going to follow that same exact pattern every time. N minus 2 times 180 over n. Multiply n on both sides. Distribute the 180. Get both ends to the same side. And then divide by whatever is attached to the n.
So is the answer octagon?
So the answer would be an 8-sided figure, which is an octagon. Yep. So if it said state what kind it is, you can write octagon. If it was something like 11 sides, it would be 11gon. Okay. Or if it says how many sides does the figure have, you can just say 8. So just look at what it says. I distributed the 180 times the n and then times the 2. So you can move the 180 to the front if that confuses you. You can totally switch those positions because you're used to distributing it to the right. But it's the same property going the other way around. Okay? So this is, like I said, just like 24, 25, and you will see something like this again, so you wanna make sure you know how to do it.